Okay, so you can see we've got our stock chucked up in the lathe, and we're just going to turn this to a nice diameter just to get a nicer finish. Then we're going to flip it, turn the other piece to bring them all into dimension, which is not critical. This is just purely cosmetic right here. And then we're going to flatten the sides, at least one of them, so we can take it over to the mill, and we'll have a reference surface for in the vise. So we're going to go ahead and just do some cleanup work here. And again, this is cold rolled steel, so we're not going to get a nice finish out of this. At least not with carbide. I could switch to a steel shearing tool and get a nicer job, but this is good enough for the puck that we're building. And one more just skim pass. Okay, and without changing anything on the cross slider compound, we're going to turn this over so we can just finish the remainder of that. Okay, there we go. Turn it over. Now we have much more material to clamp on. There we go. And then we're going to finish this to dimension and then surface this flat to take it over to the mill. Interesting, we still have more to take off there. Boy, that is a nasty finish on cold rolled. I hate machining cold rolled. I want to back that up, take a little more off. Okay, and over to the mill we go. Okay, so you can see I couldn't take it. That finish was driving me nuts. So I ground up a new tool, high-speed steel, and gave this a nicer finish. It's a hidden part. We're not even going to see it, but it was driving me nuts. All right, so now that we've got a flat reference surface, we're going to be able to skim top and bottom. I'm going to do both right now. Come on, get in there. There we go. Just to be sure we have two square surfaces. Okay. That's why I didn't really care too much about the finish on here. I just wanted them relatively square so that when they got it to parallels, that we'd be all set. So let's go ahead and tap our part down, snug it up, give it a whack, tighten. There we go. And we're going to give a nice, beautiful fly cut finish because, you know, everybody loves a fly cut finish, right? Let's get over here. Get us all lined up. Bring the head up a little bit. I like to have my fly cutter sticking out as little as possible. Give it the best opportunity for a really nice finish. So we try to raise the knee as much as we can up to the fly cutter, and then just use the quill for fine adjustment, if you will. Okay. We're roughly centered. There we go. Now to get me lined up height-wise. Right there, and a little bit more. Okay. And where are we on RPMs? Okay, we're about 1,300. We're going to bring that down a little bit when we start. There we go. And let's take a cut. Okay, get it out of here. A little off-camera deburring. There we go. Back in, snug. Tap. And a little more snug maybe. There we go. There we go. All right, let's fly cut this side. There we go. Now we're going to take the piece and we're going to rotate it on its side, fly cut a flat for the very first piece. So we'll fly cut, we'll cut the flat. I'm sorry, we're going to tip it over, we're going to fly cut a flat, then we're going to do, get lined up on center and drill our first 1/4 inch hole and our first 9/16 hole, and then do our tapping while we're set up, and then we'll do that for each of those faces. Okay, so we got our stock deburred, turned over in the vise. We're going to fly cut the flat while we still have the fly cutter installed. And then we're going to take the fly cutter out, put in the center finder, find center front to back, and drill our first 1/4 inch hole, then our 9/16 hole, and then our tap. Then we'll rotate the piece one direction, fly cutter back in, and just kind of repeat that whole process. So here we go with the first piece. Let me get the fly cutter lined up a little bit better here. There we go, and fly cutter on. Okay. Whoopsie, thought I had clearance. I did not have clearance. There we go. Gorgeous. Now we're going to swap over to the drill and do our locating and drilling. Okay, so I know I said I was going to retool, but I changed my mind because I want these flats to be equal. If I take the fly cutter out and move the table, it's going to be a really difficult time getting this flat and this flat to be the same dimension. So what I'm going to do is I'm going to cut this a little wider and while it's in here, and then keep everything in the orientation, and then we're going to rotate the block one way and then the other way in order to get our flats in here. Okay, so you can see what I've done is we recut this just a little bit wider. I wanted a little bit more. And we've clamped a stop to the side here just to give us our location. And we're going to deburr that. Just to be sure, there is a little burr on the back side. So let's just get rid of that little burr. Okay, there we go. A little burr on the front side here. Okay, nice and clean. And now what we want to do is we want to get these same flats here and here. And to do that, we're going to use our little angle finder. Okay. And okay, there we go. We're zeroed out. We're going to loosen the vise and give ourselves a turn one direction, then a turn the other direction. Okay, there we go. So we're still against our stop. Oh, a little more on the vise. There we go. And let's go for, let's see, what are we going to get? 20 degrees maybe? Nah, not quite 20, because that's still going to hit here, 25. Let's try 30 degrees. I didn't map any of this out. Probably could have figured it on paper first, but you know, this is good enough for what we're doing. And let's try 35. A couple fractions of a degree honestly aren't going to make that much of a difference, but you know, let's try and be precise. Come on. There we go. 35 degrees. Give us a little tap down, and then we'll just recheck in a second here. Okay, 35 degrees. Tighten everything up. And time to cut something. Here we go. There we go. We'll clean this up once it's off the mill, but this is really just so we don't get an interference when we go 35 the other direction. So we'll get our gauge back here. Still roughly our 35 and change. Loosen up, and we'll go 35 the other way. Okay, here we go, and for reference, here's our 3/8 NPT tap. So you can see the amount of space that we planned, and that's really what I was looking for when I was laying this out, is to make sure we had enough room for our tap to go through. So now we're already set with this as a perpendicular surface. We'll come back, you know, of course, and go each one and do our 3 operations with drill, drill larger for the tap, tap, rotate, and repeat. Okay, so here we go. You see we've got the absolutely forbidden center finder and a drill chuck. And we need to be in the center of this piece when we drill the 1/4-inch channel all the way through, because if we're not in the center, when we drill this, this, and the third side, they may not intersect. So this dimension is pretty important. However, this dimension is not, as long as they're the same. So we're going to get our center right here, and you know, we're putting a 1/4-inch hole in, so it's not like it's got to be thousandths accurate, but we do need to be pretty close in the center here, just to make sure that we don't have an obstruction in our channels. So we're going to go ahead and find center, and then we'll continue on with the drilling operations. So we're going to 0-0 this. Okay, we're going to drill down, and we have to be sure that we drill at least past the center so the 3 holes do intersect. All right, so not a big deal, but just something we have to keep in mind here. It's a 2.5-inch piece of material, so we basically have to go half that distance, right? So we got to go 1 1/4 in there. So we'll start measuring that once we get flutes to the edge. That way we're sure that everybody is to the distance, and we might even go just a hair over just to be absolutely sure. And lock our table in place. There we go. Go get our oil. Forgot to put it over here. Okay. And from here, yep, so if I go to a little over 1 1/4 here, 1 1/3 basically, that'll bring us right to where we want to be. And technically the angles we're at, I didn't measure this out, they might intersect earlier because of the angle we picked, the 15 degrees. Actually, I'm pretty positive they will. There's 1 1/4. Almost there. There we go. 1 1/3 inches. Okay, let me get these off of here and put our original stop back in place before I do our next step. Okay, now, same sort of thing. We're going to bring this down until the flute's clear. When the flute's clear, we're going to set our depth measurement just using the scale on the head of the mill up here. So you can't see that, but just trust, that's what we're doing. There we go, our flutes are just in. And I'm going to bring the hose over and put it in front of the camera so you can see exactly what I'm referring to with the tap. So you can see on the front of the tap here, there's no thread cutting here. This is just for alignment, so it centers itself in the hole. And we get about that much tap before we cut any threads. And the first couple threads aren't very good threads. They're not fully formed. So when we look at the 3/8 NPT connector, if we laid it side by side, you can see that those first few threads aren't going to do anything. So we actually have to go to pretty much the full depth of the tap to get a full set of threads for this. So because I don't want to go any deeper due to the pressure that I mentioned in my previous video, we just want to make sure that this is where we get to. So basically we need to have a hole deep enough to accept this entire length. Okay? So we want to be able to be sure we can get all the way to the bottom of the hole. That's why on the drill bit, we're measuring from where the flutes engage, because that's where this would stop at. It won't be able to go further into the cone section here. So what I'm going to do is I'm going to bring the quill down. I'm going to go up top and just see how much we have to go to. We're just measuring right off the scale up above. 1 13/16 it looks like. Yeah, there we go. I can get that back out of there. Alrighty, and we're going to come down even more. That was still fast, I think. There we go. There we go, and that is full depth. Ooh, hot chip on the sleeve. Whew. That was a warm one. Ooh, buddy. Okay, now tapping time. So let's get set up for this action. And we need a follower in here, and what I like using for this follower sometimes, it's funny, it's a center punch, spring-loaded center punch. A lot of the tap followers, the springs are just really, really weak. I'm going to build my own with a very powerful spring, so when I'm doing these heavy taps, it's pushing down with a lot more force. But for now, I just go ahead and use one of these. And all we do is give a little pressure on the quill. There we go. So we bring this down in the middle and give it some nice pressure, and then we just lock the quill. Oh, my quill lock is loose. There. There we go, and that's loading up nicely. There we go. Okay, blow that out and chamfer it, and on to the next one. Okay, so I wanted to share a mistake I made with you, and it's not critical, but it does impact the part. So again, this is one of the things that we run into when you don't do a drawing first and you just kind of wing it, you know. So we've got our hole that we drilled, and everything went fine. All right, but you see the depth of the hole in there, okay? And if we were to drill the very next hole here, the threads would intersect, and I would basically have a passage straight through and unable to thread anything in. So instead of putting a hole here, hole here, hole here, we're gonna put a hole here and a hole here, skipping this face. And then we'll just add 2 more faces here and put a hole on this part. So same exact idea as what we started with, but you know, placing the holes a little further apart. I didn't account for the width of the 3/8 tap mentally when I was going over this in my head. You know, it's a 9/16 hole for the 3/8 tap, because you know, when we're talking pipe, it talks inside diameters, and I just didn't really think about that. Okay, so I'm gonna finish this part up, pop the 2 holes in, and then we'll come back and review what we've got. Okay, thanks. So what I'm doing here is obviously adding a stop to the other side, and I'll explain this in just a quick minute here. But some of you might even already be ahead of me and have caught on to what's going on. But as we start to rotate this, we're going to have a flat side against this stop, which means we would be shifting this direction. So that would put our hole off center. So as we rotate, we're going to keep the round piece, right? Currently there's a flat side over there. You can see the amount of play when it's flat and flat, but when we have the 2 rounds, it's in there nice and solid. So this is going to ensure that there's a round side over here tangential to this portion, so then we'll have our hole in the exact same orientation. So there we go. And you can see we're back nice and snug again. Okay. Get that to 0. Little snug for sure. All right, there we go, 0.05 degrees, that's close enough. Okay, you might have noticed that I've got my chamfering bit in here, the countersink, and I've done it before tapping and I do it again after tapping. And what happens is with those pipe taps, they're tapered. That's a drastic exaggeration, but it pushes out the upward lip on the very surface here. So I put the first chamfer in to help the tap start, and then the second one goes in just to clean up the hole. There we go. There we have our manifold block. We'll take it over to the bench where we can get a closer look at everything. Okay, so here's our finished, well, nearly finished part as it came off the mill. So we got a pretty decent finish. Here I've got some chatter though. I was taking a pretty big bite for that small Tormont fly cutter. So I think I just, possibly the cutter got dull or just too much vibration. But overall, pretty good job. Let's see if you can see up in there. No, you can't, but let me get a light so you can see what we talked about the intersecting holes here. So you can see, we can see light through there and light through there. So we know that all three of these holes intersect. You can tell that when you're, there we go, down there. You can tell when you're drilling when you intersect a hole as well, because, you know, basically the resistance just goes away immediately. So as I would encounter the void drilling the second and third holes, I went through until I hit pressure again to be sure I had a complete intersection among all three of those holes. So the threads came out pretty good. You can see there's a lot of meat in here. I mean, there's a lot of material that is going to help us with that hydraulic force buildup inside that we talked about in an earlier video. And as you can see, there's a lot of extra material on here. This was intentional. I thought about cutting this off and having another little scrap, or possibly even just fly cutting it down, or taking it in the lathe, turning it down, whatever. But this gives me an opportunity, if I needed to have another set of holes that are separate from these. I don't know that I'll ever need that. You know, I can continue on the other side of the block as well. It's one of the reasons I started out with such a big chunk, is I don't know my future needs on this project. You know, will I use this manifold for more than one purpose? Who knows? But there it is. Hope you guys enjoyed it. One hydraulic manifold for a high pressure 10,000 PSI hydraulic press.